The second part that we want to visit as a part of our refreshment and preparation for calculus is the functions graph. We want to make sure that we understand the most common or famous functions, how they are drawn or how do they look like at the xy axis. As you can see in here, we have the xy coordinate system, as known as the Cartesian, referred to René Descartes, who came up with this xy axis representation for functions. So we have the x-axis on the horizontal in here, and we have the y-axis on the vertical. And remember that we have 4 quadrants for the Cartesian. We have the first quadrant and the second quadrant in here, third quadrant in this area, and the fourth quadrant in this area. Then if you have a point on the Cartesian, then you represent it through a point represented by x and y. So in this case, x is 8, y is 3. In this way, you are declaring a point on the Cartesian or the xy coordinate system. For the common functions, if you go to a function that's saying it is y equal 3x plus 5, as you remember, you use the needed equations to find the points where this function is crossing the y-axis and where's the points that this function is crossing the x-axis, and you connect between those, and this line would represent this equation on the Cartesian. If you have y equal x squared minus 2, same thing, you see where this function is crossing on the x-axis and y-axis, having 3 points in this case. We know that this is a quadratic equation. If you have y equal the absolute value of x, then this is how it look like. As you remember, y equals sine of x, it will be a sinusoidal form, as you can see here. If you have an equation that's representing a circle, in this case x squared plus y squared equal 9, then you represent the 9 with this dotted line in here, and x squared plus y squared equals 0. That's a full circle with origin on the axis, or the origin of the axis, the point 0 and 0. If you have a more complicated function, x equal y cubed minus 5y squared plus 10, then that's how it happened to have the function to look like. Now for inversed functions, if you have a function of x equal x squared, then this is how his graph is looking like. And y equal x, this is how the graph is looking like. F inverse of x equal the square root of x, this is how the graph is looking like. For logarithmics, if you have f of x equal 2 to the power of x, that can be written in the logarithmic form g of x, or you can say f of x, same thing, equal the logarithmic of 2 of x. In this case, can be written in this way. Now, having the horizontal transformation, some functions with changing some values, you'll have horizontal transformation, means the function will move along the x-axis, or vertical transformation, that means the function, same graph, same shape, but it moves on the y-axis. So here we have y equal 2 to x to the power of x plus 3. So since you say y equal 2 to the power of x plus 3, then in this case, this is how the graph is looking like. Now, if you multiply the value of x with numbers, or you add or subtract some numbers to the x, then you are having horizontal transformation on the x-axis. So you can see here y equal 2 to the power of x, here y equal 2 to the power of x minus 3, and so on. So you are transforming on the y-axis either to the right or to the left based on the values you're adding or removing from the equation, as a multiplication to the value of x, subtraction, addition, or division. Again, another horizontal transformation, you have y equal 2 to the power of minus x, and you have y equal 2 to the power of x, so the exact opposite for the value of x. So we have plus x in the power here, we have minus x in the power here. In this way, both of them are passing through the same point on the y-axis, but they are forming the same shape, but in a mirror kind of feature. So that's a really quick visit for the functions and how they look like, just to make sure we are sharpening your memory and bringing back some nostalgia for you, and hopefully we can bring back more of your memories of the other topics that we need to know as we are moving towards starting to learn about calculus.